Hey everyone, welcome back to iTower. In today's video, we're diving into a topic that looks simple at first glance, but actually causes a lot of hidden bugs in real applications, and that is deep cloning in JavaScript. There are many situations where a developer copies an object, modifies a value inside the new one, and then unexpectedly notices that the original object has also changed. This confusing behavior is caused by what's known as a shallow copy, and it can seriously affect data integrity, especially when working with state management in front-end frameworks or manipulating data in larger applications. Before we jump into the code, make sure to like the video if you're excited about this topic, and don't forget to subscribe to the channel. It really helps the channel grow, and you'll stay up to date with all our tutorials. Alright, let's get started. To understand the issue, it's important to know how JavaScript treats complex data types like objects and arrays. These are reference types, meaning that variables don't store the actual value, but instead they store a reference to a place in memory where the data lives. So, when you assign an object to a new variable, JavaScript doesn't create a new copy of that object. It simply points the new variable to the same place in memory. That means changes made through one variable will reflect in the other, because they are both accessing the same object. Let's take a basic example. Suppose an object is defined with a user's name and address. The address is itself another object nested inside the main object. If a new variable is created using the spread operator, it may seem that a new object has been made. However, what happens under the hood is that only the top-level properties are copied. The name property, being a primitive string, is copied by value. But the address property, being an object, is still copied by reference. This means that both user and copied user are pointing to the same address object in memory. As a result, if the city property of the copied user's address is changed to Paris, the change will also affect the original user object. This happens because both of them are referring to the same nested object. This behavior is not always obvious, but it can lead to subtle and hard to find bugs. To solve this problem, a technique called deep cloning is used. Deep cloning means creating a new object that is completely disconnected from the original, including all nested objects and arrays. Every level of the structure is duplicated into a new memory location, ensuring that changes in the new object do not affect the original one at all. One simple way to achieve a deep clone is by using JSON methods. The idea is to convert the entire object into a string using JSON stringify, and then immediately parse it back into a new object using JSON parse. This method creates a new object in memory with a completely independent structure. Changing values in deep copy will not affect user because there are no shared references. However, this technique has significant limitations. It only works with data that can be represented in JSON format. Any functions, special object types like date, map, set, or values such as undefined will either be removed or misrepresented. In particular, date objects will be turned into strings, and functions will be discarded entirely. For example, consider an object that includes a date and a method. Using the JSON method in this case will result in birthdate being converted into a string, and the greet method being completely lost. This can break functionality if the cloned object is expected to behave the same as the original. To overcome these problems, a more flexible approach is to write a custom recursive deep clone function. This kind of function examines each property, and if the value is itself an object or array, it creates a new instance and repeats the process for each nested level. It also includes logic to correctly handle special types like date. Here is a basic version of such a function. This function starts by checking if the input is null or a primitive. If so, it returns it directly. If the value is a date, it creates a new date with the same value. If the value is an array, it maps over each item and applies the deep clone function recursively. For plain objects, it iterates through each key and calls deep clone on the value, building a new object from scratch. This solution is much more powerful than the JSON method, and it supports many real-world use cases. But even this function doesn't handle all possible JavaScript types. For example, it does not support circular references, where an object refers back to itself, and it does not cover instances of map, set, regex, or class instances. For complete and reliable deep cloning in production, a third-party library is often the best solution. One of the most trusted libraries in the JavaScript ecosystem is Lodash. Lodash provides a function called cloneDeep, which handles almost every edge case and data type you can imagine. The syntax is simple. This method takes care of nested structures, circular references, date objects, maps, sets, arrays, and more. It is heavily tested and widely used in production systems. Using a library like Lodash reduces the risk of bugs and saves time when working with complex data. In modern JavaScript, there is also a native method called structuredClone. This method is now available in most modern browsers and Node.js environments. It is a built-in way to deeply clone objects, and it offers great performance and support for many advanced types. StructuredClone supports date, map, set, array buffer, and even handles circular references. However, it still does not support functions, DOM elements, or class instances. Despite that, for many applications that deal primarily with data rather than behavior, structuredClone is a fast and reliable choice. To summarize everything, shallow copying only clones the top-level structure, which means nested data remains shared. This can cause bugs when changes in one object unintentionally affect another. JSON methods offer a simple deep clone, but are limited to safe JSON values. Custom recursive functions provide more flexibility, but still have edge cases. Lodash's cloneDeep handles almost everything and is a great choice for production. And the native structuredClone function gives you a fast and modern alternative, with good support across platforms. Understanding how deep cloning works helps you avoid hidden bugs, especially when working with data transformation, state management, or API responses. Mastering this concept will make your code safer, cleaner, and more predictable. If this video helped you learn something new about deep cloning in JavaScript, be sure to like and subscribe to iTower. Thanks for watching, and I'll see you in the next video.